Bonjour à tous! Bienvenue à ma chaîne YouTube aujourd'hui. Merci d'être ici et bon visionnage. Today on my workbench I have Gary's QuadraFire brand pellet stove controller. This controller is a model TASSB-93V.12A. Gary sent me this one because he was having issues with it. He told me that once the fire pot overfilled with pellets and drowned out the fire or swamped out the fire, and that he was hearing ticking sounds coming from the inside of the controller. So when you do hear ticking sounds coming from your controller, you're on the verge of killing your controller completely and it needs to be repaired. Otherwise, if you let it go, it may not be repairable in the long term. As you can see, I have Gary's controller connected to my test system. My test system is made up of a few items. Firstly is a wiring harness here that connects the controller to it. I also have a thermostat, just like the one on your wall. That's an on-off switch basically. I have a temperature simulator that I'll use to simulate the temperature of the fire pit so that the controller can do different things for us. I have a faceplate that mounts an actual auger motor on it. The shaft from the auger motor comes out the front. I have a decal on it, the X marks the spot decal. So when the controller is calling for the auger to drive, you might hear it in the video. You'll also see it here spinning, and you'll see one of the light bulbs at the back come on. Speaking of those light bulbs, I have 4 of them. One of them simulates the igniter in your stove. The next one simulates the combustion fan, the firebox fan. In yellow, I have one that simulates the auger motor. That's connected to this motor, by the way. And at the far end in red, I have a light bulb that simulates the convection or room fan. For this kind of controller, that light will not come on because that light is controlled by a thermostatic switch, which is inside your pellet stove itself, and it only operates when the body temperature of the stove gets high enough. So I have everything going. Before I get started, I'll say a couple things. There's 5 timers inside the box. I checked them all out. They're working fine. I also marked on the box that the green light here will come on at 285 degrees Fahrenheit, and the red light over here will come on at 1335 degrees Fahrenheit. So let me turn things on. I'm not calling for heat. So the exhaust fan should come on for sure, and there it is. The exhaust fan is cleaning out the whatever air is in the firebox and getting things ready, making sure we have a low pressure zone in there so that the auger will function. So if I do a call for heat, I'm simulating a temperature of 58 degrees Fahrenheit now. If I do a call for heat, let's see what happens. 2 things happen. The igniter has come on, so the igniter is going to try to ignite pellets that are in the fire pit. And in yellow, the auger motor has come on. You can see a spin here as well, and you may hear it in the video. So for 2 or 2.5 minutes, if we don't do anything, this is what's going to happen. The auger is going to dump pellets into the fire pits at a speed of 1 RPM, and the igniter is going to try to ignite those. After about 2 minutes, the auger motor will stop running, but the igniter will stay on for another 7 or 8 minutes. So that's a way to get the fire going. So let's say that the fire is slowly simmering and it's increasing. So as the temperature rises on it, we're going to approach 285 degrees Fahrenheit. And as we do, we see the green light has come on. The green light over here. So if I go down, the lamp goes off, on, off, on, off. I hope you can see that in the video. So that's working normally, and all the lights are still functioning correctly because we're really in startup mode here. And as I increase the temperature to a little over 1335 F, we'll see the red lights come on. And when we do, lights at the back will change status. So we're approaching it now. There it is. Notice what happened. You hear a click in the controller, and the igniter is turning on and off. So basically that's saying that the temperature of the fire is hot enough, it's self-sustaining, the pellets are burning, the thermocouple is reading a high temperature, and we're calling for heat. So that's going to stay that way for a while until the room warms up enough to do a stop calling for heat. So to stop calling for heat, if the room is hot enough, the thermostat would shut off, the auger would stop, the fire would continue, but it would slowly diminish, and then the room may cool a little bit. And as it cools, the thermostat will do another call for heat, and more pellets are dropped in, the fire reignites, so to speak, or it becomes more sustained, it's stronger, a stronger fire. That heats up the room, the thermostat will call for off, and that goes off. So that cycle will keep going. Cool, so we're going to heat up the room. Room's getting hot, thermostat stops calling for heat, no more pellets, the room will cool slightly. As the room cools, we call for heat, and on and on. That will keep on going until we either run out of pellets or somebody decides enough, the room is hot, I have no need to heat it anymore. So in that mode, we turn off the pellet feed, the fire temperature will slowly diminish, and the room will go back to a temperature of 60 degrees as the stove slowly cools. So there we have it. Gary, as you can see, your pellet stove controller is once again fully functional. I do want to thank you very much for sending it to me. I appreciate that. For all you other viewers out there, if you have a pellet stove controller of your own that you need service for or you think you have questions about, please feel free to contact me. I'd be more than happy to discuss those with you. My contact information can be found in the video description just below this video. In the meantime, I hope you'll take a few seconds to give this video a thumbs up and subscribe to my channel. I would appreciate that very much. Thanks everyone. Bye bye.